Welcome back, chemistry students, to our Chapter 5 podcast. I'm Ms. Rashar. I'm going to be taking you through Part 2, which is all about electrons and atoms. So before we start, we need to go over what we've already learned. So in the last podcast with Mr. Sustin, you talked about what light is, and specifically you looked at the wave-like properties of light. But if you recall, Bohr then explained that we also had these quantized bundles of energy, which again we called photons. So introducing those photons also introduced another issue. Are we looking at waves of light or particles of light? And if we're looking at particles, can we calculate the energy that those particles or photons release? So here we have a picture of an emission spectra for 5 different elements. And one thing to notice is that at the bottom you'll see your wavelength. And what's happening is as that wavelength is decreasing, you also see a difference in the color being emitted by the electrons. You also will notice that as your frequency is increasing, your wavelength is decreasing, and we can calculate that using our wave equation from the last podcast. When we can use all of that to help us calculate the energy being released by that photon to give us that light emission. We do this by what's called the Planck's equation, which was developed by that awesome guy on the right-hand side there, Max Planck. He developed an equation that helped us to determine the energy of the photons. So what he determined was the energy of a photon is proportional to the frequency of light emitted when you are observing the emission spectra. So in other words, if your frequency of light is being increased, so is the energy of your photon. And if you decrease the frequency of your light, then you're also going to decrease the energy of that photon being released. To do this and to give us the equation, he used a constant which he named after himself, Planck's constant, to describe the proportionality between that energy of photon and the frequency of light. So here's the equation he gave us. He took that the energy of a photon, E, is equal to Planck's constant, H, which is 6.626 times 10 to the minus 34th joules seconds, times the frequency of light observed, F. And you'll recall this frequency is the same one given to you in your wave equation from the last podcast. Putting that all together, he came up with the equation E equals H times F, or the energy of a photon equals Planck's constant times the frequency of light observed. And we can use this equation not only to calculate the energy, but if you are given the energy, we can calculate the frequency, and if you're given the frequency, you can also calculate the energy of a photon. All right, so thanks for joining me for this Part 2 of Chapter 5. Please remember to watch Part 3 as well.